Hey Intro to Calc, I want to make a quick video showing you some of the con exercises you're going to see this week. So before I head into that, I want to show you that these are part of assignment number 1. So these are due the first half of the week. You should be working on them earlier in the week, Monday, Tuesday. Bring any of your questions to office hours, but let's explore some of these together. Make the most of this video by pausing it, fast forwarding it, rewinding it, or changing that playback speed if I'm talking too fast or too slow. So cool, let's go to evaluate trig functions, or their inverse trig functions. And if you guys didn't know, if you're always logged in to Con, when you click on that link, it should take you directly into the practice problems. Make sure you're logged in though, because if you're not logged in, you won't get the credit for it. Okay, so this one says the following are angle measures in degrees. That's going to be important. In degrees. Rounded to the nearest tenth, whose sine is negative 0.71. What is the principal value? So if we are to look at our unit circle, our values repeat. So an inverse sine of 0.71 is going to end up somewhere over here, but it's also going to end up somewhere over here. It's going to end up on both of them. Well, the principal value is always going to come from the first quadrant. So technically that principal value, when we're talking about degrees, is always going to be between 0 and 90. So how does that account for a negative value? Well, when we find where that is positively, let's say it's up here, we just say that is a negative. So let's say, for example, this was 60 degrees. It's not. Because this is a negative value and we actually need it in the fourth quadrant, we would call it negative 60 degrees. So we're really looking at values in the first quadrant and the fourth quadrant. So let's find that principal value. I'm going to go ahead and type this into my calculator. So arc sine is the same thing as inverse sine. So your calculator function looks like this. And I use Desmos' scientific calculator because it's really easy to switch between degrees and radians. So I'm going to hit the inverse sine button and put in negative 0.71 and make sure I'm in degree mode. And it actually is giving me the angle that I need. It's giving me negative 45.2349 ... And awesome. That does actually lead me to right where I was hoping to find it. And that is my principal value, because if I look at the absolute value of this number, it is between 0 and 90. That's exactly what we want to see. So let's go ahead and let's select that answer of negative 45.2349, which we're going to round off to just 2. Okay, let's try another one. It says the following are angle measures in radians. Like I said, we're going to be switching back and forth. So now we're in radians, whose sine is 0.98. And again, this is the same thing as inverse sine. It's just a different way of writing it. So we're looking for the principal value. Just as a reminder, the principal value will always come from either the first quadrant, meaning 0 to 90 before, but instead of 90, now we're doing pi over 2, which is about 1.57 and some change. So we want to make sure we have a number between 0 and 1.57, or just the negative version of that. So let's go ahead and put this in our calculator. Making sure to switch your calculator to radian mode. So when I switch my calculator over to radian mode, I get 1.37046 ... And just a quick check does tell me, yeah, it is somewhere right here in between 0 and 1.57. So yeah, that is my principal value. And when I round it off, that leaves me just 1.37. So let's try that out. Cool. Okay, so let's check out the second set. The second set, solving sinusoidal equations basic. This is tricky. I'm giving you that heads up right now. This is tricky. Please, if you're struggling with these, bring them to office hours, jot them down. I would love to try one of these with you, but I'm going to give you a few examples. So here we have a very, very similar equation. This right here, when we go to solve it, x is going to equal the inverse sine of 0.25. Or what this question is actually telling me is it's saying, I have an angle where the sine is 0.25, tell me that angle. Well, that's inverse function. But if you notice, I have expanded my interval. I don't just want the principal solution. I want every possible solution from negative 270 all the way around to positive 270. So let's start off by finding the principal solution. Let's find just that very first solution, making sure to switch my calculator back to degrees. I'm going to plug in inverse sine of 0.25. And when I'm in degrees, I actually get this is 14.4, I'm going to round it off, 48 degrees. Cool, that's right here. So we have that principal solution. But now I want to think through every possible angle that has that same sine or that same y value. Well, it's going to be over here also, which is just 14.48 shy of 180, or 180 minus 14.48, which is 165.52 degrees. So cool, I've got two solutions to start off with. But let's actually make our way around the unit circle or around the circle with the guidelines they gave us, starting at negative 270 and going all the way to 270. So if this is 0, this up here is negative 270 degrees. Okay, negative 270. As I start going around the circle, bam, I hit my very, very, very first iteration of that angle. I hit that first iteration of the angle. And if this right here is still 14.48, well, then this is just 14.48 past 180. So I have kind of like a 180 minus 14.48 degrees. Which is negative 194.48 degrees. So there is our actual first time we hit that angle. First time. Let's keep going. We keep going around. Now that's negative 180. Here we hit negative 90. Here we hit 0. So now we still just have this one iteration. But we need to keep wrapping around to positive 270. So let's keep going. Here we hit the next iteration of the angle. So we need that guy also. Okay, here we rotate up to positive 90. And here we hit the angle again. That is that 165.52. Okay, let's keep going around. That's 180. And bam, here we hit 270 and stop. So if we kind of go back through, we hit it once, twice, 3 times. So we need the 14.48, the 165.52, and we also need that negative 194.48. Okay, let's try another. This one you're going to see expressions. So this one we're going to do that same work, but we're not actually going to calculate it. We're just going to say, well, let's imagine it going around and around and around. Same idea here. We're being asked to solve for x. So that means x equals the inverse sine of negative 0.7. Let's start by finding the principal solution. I'm going to put this into my calculator, making sure that I am in degree mode. 0.7, so the inverse sine of negative 0.7 in degree mode is giving me negative 44.4 0.43. Thinking about our circle, negative 44.43 is right here. That would be that sine value of negative 0.7. But I want all of the solutions. So every time we rotate around the circle, we're going to come back to that point right there. So we have negative 44.43, but another rotation of the circle plus 360 will come right back to it. Another rotation of the circle will come right back to it. Another rotation of the circle will come right back to it. So a great way to write that is negative 44.43 plus n times 360, meaning every rotation from there on out. But think again, sine is a y value. Where else do we see that same exact y value? Well, on the opposite side, right here. Which this angle is still negative 44.43. So in this case, we are just 44.43 past 180. So 180 plus 44.43 That's one way we could think of it. And again, every single 360 will come back. Every single 360 will come back. So we would want to have 360 times n. So we know one of the solutions is there, but I don't see my 224.43. Let's see if it exists or if we have to write it in a different form. So we like this one. But yeah, I don't see that one. So let's try to write it in a different form. So if I know that I'm in the right place, I have that correct marking right there, we could write it instead as a negative angle. Let's write it instead as a negative angle, meaning instead of thinking of it going this way, we actually think of it going this way, which instead of adding that 44.43, we would be subtracting that 44.43, because we would just be 44.43 shy of 180. And when we do that, we get a negative angle of 135.57. So going backwards, that would be rotating negative 135.57. And I do see that there. So that's the angle we want to choose. So, like I said, these ones are kind of tricky. I've only assigned you 4, and I want to help out. So please feel free to ask a question, bring it to office hours, post it on the stream in Google Classroom, and we'll work through these. Have fun with these guys, and I will